Hello, welcome everyone. Now we are going to deal with work done against gravitational force. So, work done against gravitational force. So, if we lift a bucket of water from the ground, right, we do work against the force of gravity. So, suppose this is a bucket and we are lifting it, okay. So, force is applying upward and this is external force, and in the form of external it is what? Man. And force of gravity, gravitational force, is equal to m times g. Suppose it has mass m and it is acting vertically downward, okay. So external force is applying upward and it is getting displaced upward. So work done by an external force, which is here man, this is equal to F into S with plus sign, because force is also upward and displacement is also upward. But work done by gravity, by gravitational force, gravitational force is acting vertically downward and it is getting displaced upward. So angle between these are 180 degree. So of course work will be minus mg into s, right? This is minus mg into s, that is minus f into s. So what I want to teach all of you is that work done by external agent, and this is external force, this is external force. So I just want to teach all of you that this is external force, and external force is acting upward, and gravitation, this is external force, F external force, and here in the form of external force is man, and this one is gravitational force, gravitational force. So here we have written the heading work done against gravitational force. So this is gravitational force, so of course this force is against gravitational force, right? Against gravitational force. So it will turns out what? Force into displacement and magnitude of force. Suppose it is moving with very slow speed, or suppose here we have written, suppose this is F and this one is W, and we generally lift the bucket in very slow speed. So F is approximately what? Mg. This upward force is equal to downward gravitational force. So this will turns out magnitude of force is equivalent to mg, and suppose s is equal to h, so it will turns out what? Plus mgh. So this is work done against gravitational force, okay. So work done in lifting, in some question it will be asked the work done in lifting a body. So that is nothing but simply the weight of the body multiplied by vertical distance, okay. Now I just want to tell once again the same thing. If we lift a bucket of water from the ground, okay, we do work against the force of gravity. When a body is lifted vertically upwards, the force required to lift the body is equal to its weight. Thus, whenever work is done against gravity, then amount of work done is equal to the product of the weight of the body and the vertical distance through which the body is lifted. Okay, so these are the conclusion. And here body of mass m lifted vertically upward through a distance h. So force required to lift the body will be equal to weight of the body mg. G is nothing but simply what? Acceleration due to gravity. And work done in lifting the body will be weight of the body multiplied by vertical distance. One more important thing I just want to put forth is that work done work done by a force acting obliquely. Through telling obliquely, I just want to tell at an angle, not 0 degree and not 180 degree. So force is acting obliquely. Suppose this is acting at an angle theta. So this is m and it is getting displaced through s. Okay, so this is getting displaced through s. So we will have to think that the effect of this force in the direction of displacement, and this is right angle triangle. So of course this act as a base and this act as a perpendicular, so of course this will be, and this is acting as a force, so this will be f cos theta. So in case of obliquely, when force is acting obliquely, work done is nothing. Work done is equal to f cos theta multiplied by s, that is component or also known as effect. This is component or effect of applied force. Component, so called effect of applied force in the direction of motion multiplied by what? Displacement. Okay, now I am also going to explain some more thing. Nature of work. So I have already stated before you earlier that work, as far as nature of work is concerned, so work can be positive, can be negative, and can be what? Zero. Positive when force and displacement acting in same direction, 0 degree. Negative when force are opposite to the displacement, and 0 when angle between them will be what? 90 degree. Angle between force and displacement will be, and where theta is angle between what? Force and force and displacement. So this is nature of work. So positive work, if you are pushing something, suppose this is a body, this is a trolley, and someone is pushing it in this fashion, so it is getting displaced to the getting displaced to the right, so in this case work is positive. Okay, but suppose someone is running through a cycle. Suppose this is a cycle. I am not expert to make good cycle, but suppose this cycle is going to the right, and some a student started to pull it to the left. So after a while it will go certain distance and will stop. So in this case force is to the right, sorry, force is to the left and displacement is what, to the right. So work done by the force is what, negative. And suppose there is a coolie. This is a coolie, right? This is a coolie, and he has put certain box over his head, and he is moving to the right or to the left. So in all this course, for the scope of or the possibility of force is only perpendicular, and displacement is either to the right or to the left. So in all the cases force angle between force and displacement is 90 degrees, so work done will be what, 0. So I think you understood all these things. Okay, so regarding positive work, I want to tell all of you that regarding positive work done is said to be positive if the force applied on an object and its displacement are in the same direction, or angle between the force and displacement of object is less than 90 degree, so called acute angle. Second thing is that negative work done is said to be negative if the applied force on an object and its direction of motion are opposite, or component of the applied force and direction of motion are opposite, or angle between the applied force and direction of motion should be obtuse, theta should be greater than 90 degree. Okay, and zero work done when theta will be what, 90 degree. So there are when work done will be 0, I am putting this point, work done will be 0. Either I am talking about when work done will be 0. So case first, either force acting is 0, or second, displacement is 0. Displacement is what, 0, or C, angle between applied force and its displacement, is what, 90 degree. Okay, I am giving you one interesting situation in which, suppose there is a string, this is a string, and someone tied a stone at one end and it is whirling in a circle. So of course this is string force which is always acting towards its center. So in this case work done by a string will be 0. Why it will be 0? Because at all position displacement is tangentially and force is radially, so angle between them is 90 degree. So due to 90 degree factor, okay. So now I am giving you one example through numerical. I just want to put the thing before you. An object thrown at a certain angle. I am writing a question. Through question I just want to teach something. An object thrown at a certain angle to the ground. This is question. To the ground, moves in a curved path and falls back to the ground, right? The initial and final points, the initial and final points of the path of the object lie on the same horizontal line. What is the work done by force of gravity on the object? Okay, so since situation is like this, uh, situation is like this is initial position and this one is final position. Initial position ip and final position this, and this is displacement. So throughout, force of gravity force of a gravity acts vertically downward. So since initial and final point of the path of the object lie on the same horizontal line perpendicular to the direction of gravitational force, so work done will be what? Because theta is what? 90 degree. So work done will be 0 because theta is 90 degree. So this is important thing, and in this case no work is done by the gravity. Okay, so in next lecture we will discuss about energy. Thank you so much to all of you for showing your great patience.